Once you've highlighted each of the three angles, I want someone to tell me why those three have to be congruent. What do you think, Marcos? They all intersect at the same 2 points. So let's say we knew what the arc length of PQ was, and let's say we knew it was 120 degrees. What would that tell us about the three angles?
They'd all equal to 60.
Very good. Each of them is equal to 60 degrees. So guys, it doesn't matter where you create your inscribed angle, as long as the 2 points where they meet on the outside of the circle is the same, all three of those angles are going to be the same, okay? All right, let's mix things up a little bit. Let's say this is the center of the circle, and this is Z, point Z. What's the measure of angle PZQ? Nope.
30.
It's not 30.
60.
Mm-mm.
130.
Nope. Central angles are going to be the same as what? Remember, they're just going to be the same as the measure of the arc. Okay? So if that arc PQ was 120, then PZQ going through the middle of the circle has to be 120 as well. Think about when you stretch that vertex to the edge of the circle, you're actually just dividing the arc by 2. That's how you can think about it. So if you move it back to the middle, it's just going to be the same as the length or the measure of the arc. So, Theorem 10.14, tangent and intersected chord theorem. If a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. Okay? This is basically the same thing as the last one, only we're not dealing with an inscribed angle, we're dealing with a tangent and a chord, okay? So both the chord and the tangent meet up at point A, right? The angles that they create will also create 2 separate arcs, right? So there's the blue arc and there's the red arc, okay? The red arc is going to be 2 times whatever the angle of A is, or angle 1, okay? The blue arc is going to be whatever angle 2 is times 2. Very, very, very similar to the inscribed angle theorem, okay? So let's just do an example. Let's say that the red arc is 100 degrees. What would angle 1 be? 50 degrees. And let's say if that's 100 degrees, the arc BA, what does BCA have to be? Not 180. Remember, it would be 180. What?
260.
260. Why?
Because 360 minus 100.
Yep. It's just 360 minus 100. So if that's 260, what does angle 2 have to be?
130.
130. And should angle 2 and angle 1 add up to 180? Yes or no? What do you guys think? Should angle 2 and angle 1 add up to 180?
Yeah.
Okay, but why?
Because 130 plus 50 equals 180.
But why should they add up to 180? Yeah, they're supplementary. They're a linear pair, okay? If we added those two angles together, we get that straight line, right? Do you see that? We get that tangent line. So this is going to be true for all of these examples. You can always double check by being like, okay, does this angle plus this angle equal 180? Yes, in this case it does. Okay, next slide. All right, there's another theorem in this lesson called the angles inside the circle theorem. If two chords intersect inside a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. Guys, this sounds way more complicated than it actually is, but a little note that I want you to put on the side over here is that these are not central angles. And they're not inscribed angles. Okay, and then you guys can copy down the rest. But I want you guys to put that they're not central angles and they're not inscribed either. So check it out. Let's say we knew that the red arc was 80 and the blue arc was 40 degrees. The measure of angle 1 is going to be 1/2 80 degrees plus 40 degrees. In other words,
How are you?
hi. Okay, so when we get this is the measure of angle 1 equals 1/2 times 120. So the measure of angle 1 is 60 degrees. What's the measure of angle 3? If 1's 60, what's 3? Yeah, it's just 60, okay? Because they're vertical angles, they're going to be the same, okay? So then angle 2 would be BC and AD, right? Now, don't get confused and think that BC has to be 100, right? It's not exactly half. We don't know that this BD goes through the center. We don't know that for sure, okay? So don't just assume that. It'll have to give you BC and AD in order for you to figure it out, okay? Don't jump to any conclusions. All right, in this case, the bigger arc minus the smaller arc. So what I want you to write is the measure of angle 1 equals the big arc minus the small arc all over 2. That's it. So the measure of angle 1 Just a little definition, circumscribed angle just means that the angle completely consumes the circle. Do you remember how we would have circumscribed triangles and polygons? They were completely inside that circle. Same thing for an angle. It's just an angle that includes your circle and it's tangent to both sides of the circle, okay? So A is a point of tangency and C is also a point of tangency, okay? All right, we're skipping this slide and let's get to the examples. Okay, so in example 1, we're going to apply every single thing we learned in this lesson, okay? So UT is tangent to the circle. We want to find the measure of the arc WT, and that is this arc right here. We want to find the measure of the arc WT. Now, how we do that, okay, is we have to set up an expression for the angle WUT. Okay? So everyone right now take out a different colored, I don't know, pen and draw over kind of thick. Let's see. Where's the, here we go. Maybe the third. This line all the way out to our angle. And then this line all the way down. Okay? Now, even though this picture isn't really drawn to scale, okay, it does tell us in the beginning that UT is tangent to the circle, okay? So we know that this UT, this segment, only touches our circle one time. So T is a point of tangency, okay? The other arc that's created by this angle is this arc in green going from here to here, from T to S, okay? Now, let's set up our equation. The measure of the angle WUT, that's this angle right here, okay, is going to be equal to, since our angle is outside the circle, it's the difference of the bigger arc minus the smaller arc. So it's going to be big arc minus small arc, all divided by 2. Okay, so then let's take a look at our diagram, okay? The measure of our angle is 30 degrees. So instead of the measure of WUT, we're just going to put 30 degrees equals the big arc here. What's the big arc here? What's the measure of it? Come on now, peeps. Is it the red arc? Is that one bigger, or is it the green arc? The green one, right? How big is the green arc? 100 degrees. So put equals 100 degrees minus, what's the measure of the small arc? We don't know. That's what we're trying to figure out, okay? So just put WT. And then all over 2. Okay? You can put a little arc symbol above WT so you know it's an arc. All right, so how we are going to solve this, since WT is on the right, we need to get WT by itself. So you just multiply both sides by 2 to get rid of that denominator. We're going to get 60 degrees equals 100 degrees minus WT. We would subtract 100 from both sides. You would get negative 40 degrees equals negative WT. And then you can divide by negative 1 to get rid of that negative. So 40 degrees equals WT. So we know this little arc up here is 40 degrees. The arc in red is 40 degrees. Okay, from here, it then asks us to find the measure of the angle TVS. Okay? Well, TVS is this angle right here. okay? Now, our vertex is V for this angle, and it's inside the circle. So we're no longer using the difference, okay? When we were outside, when we were at U, right, we took 100 minus 40. Do you guys remember that? See over here, we did 100 minus WT. In this case, we're inside the circle. We're going to use the sum. So we're looking at the arc across from this and also behind our angle, okay? So we're looking at 100 degrees and 110. The measure of angle, what was it? TVS equals 100 plus 110 divided by 2. Remember, when you're inside the circle, you want to add the two arcs and then divide by 2. All right, now we have this. So the measure of angle TVS equals 210 divided by 2, which is 105. So the measure of this angle is 105 degrees. Next, it is asking me for find the measure of the angle RVS. Any ideas on what this angle will be in green?
40.
What's that, Karen?
40.
It's not 40. So I would agree it would be 40, Karen, if this V was the center of our circle, right? But it's not. $40 all over 2. Multiply both sides by 2. 150 equals RS plus 40. Subtract 40 minus 40. We get 110 equals RS. Now, another way you could have figured it out, okay, I know all parts of the circle except for RS. You could have done 360 minus 110 minus 100 minus 40, and you would have also gotten 110 degrees, okay? Because this is the only section we didn't know from our circle, you can always do 360 and then minus the other parts of the circle, okay? All right, so we found each of those examples, okay? We're gonna do 2 simpler examples and then we're done with this lesson, okay? The next example, example 2, find the measure of the arc AB, find the measure of, if the measure of arc AB is 105, then the measure of angle D equals, okay? The measure of angle D equals, here's our angle. So this angle creates a small arc and a large arc. It tells us that the measure of our small arc, AB, is 105 degrees. Agreed? That's the only piece of information that it gives us. So the measure of angle D is going to be equal to the big arc minus the small arc divided by 2. I'm using subtraction because my vertex is outside the circle, okay? You add them together when your vertex is inside the circle. So we're using minus. Our big arc, we don't know, but can we figure it out?
365.
Very good. How'd you get that?
360 minus 105.
Excellent. So we know that there's 360 degrees inside this circle, right? On the outside of the circle. And we already used 105 over here. So we have to have 255 as the big arc in order to create the entire circle, okay? So we've got 255, we've got 105. So all we do is we take the difference of them. So the measure of angle D equals 255, which is the large arc, minus 105, which is the small one, divided by 2. We're going to get the measure of angle D equals 150 divided by 2, which is 75 degrees. Done. Example 3. We want to find the measure of AB. Take a look. Take a look at the angle. Is our vertex inside or outside the circle, peeps?
Outside?
Outside, okay? So we know right off the bat we're going to use subtraction in our formula. Okay? We know we're going to use subtraction. So the measure of this angle, let's call it angle C. The measure of angle C is going to be equal to what? Good. AB as an arc minus 20. That's the small arc all over 2. Good. So we've got a big arc, which is the red one, a small arc, which is the 20, and we're just subtracting them, okay? Now, we already know the measure of angle C. It's what? 10 degrees. So 10 equals AB minus 20 over 2. How do we solve this? Yep, multiply by 2 to both sides. We're going to get 20 equals AB minus 20. And what's my last step? Add 20 to both sides. 40 equals AB.